I'm Scott Herold. I'm a senior manager of product management at Red Hat. I'm also one of the OpenPOWER Foundation board of director members. So here today to just talk about things that we've done at Red Hat to kind of help rethink the way that we deliver an operating system to help with application development for the Power architecture. So quick agenda talking about how x86-64 still kind of factors into the equations of how we operate. Talk about the value that the OS still provides to modern systems today, how we enable our hardware partners, how we look to attract the right ISVs into the ecosystem, and a quick little brief slide about just Red Hat and you. So one of the quick things that I want to highlight, someone has to talk about the elephant in the room, is if you look at the overall market share out there, there's no secret who owns that. It's the x86-64 space. Trying to take the market data that we see from all of the analysts and say, why should people invest in Power? Why should people invest in the ARM architecture? Why should people continue to invest in S390X or mainframe? There are a lot of very good reasons. Trying to share that with executive leadership also often faces challenges. How do we convince these executive leaders that look at numbers and data like this and say, why should we care about Power? What is the value that we can get out of something like that? Second one that we run into is our product teams, our developers. The model that we used to run by was every single product team would have to take a portion of their engineers and say you have to go port something over to the Power Big Endian architecture. Or now we have Little Endian, now you have to go redo some of that work. It wasn't a very healthy model for our internal engineers, our internal development teams, and it was disruptive to our product lines and what their route to market and their business plans were. That was the third thing, is how do we avoid that disruption to the core business, what our products see as the market opportunity, and telling them, wait, stop, we need to make sure that this works on Power as well. So a lot of internal politics, a lot of internal discussion. At the end of the day, we actually managed to get through a lot of those in conversations with IBM, many partners that we have in the overall ecosystem, to the point where we convinced our executive leadership. And the simple response that I got was, don't fuck it up. Plain and simple, is there are absolutely opportunities that we see for the Power architecture. And we realized that in order to be successful there, Red Hat had to change the ways that we approach the operating system to get there. First and foremost, one of the things that we've suffered probably a little bit more than any other distribution out there is parity across the operating systems. If you take a look at RHEL for x86 versus RHEL for Power versus RHEL for mainframe, every one of those had a different set of capabilities that were available or not available. And we saw that as a big challenge. What we needed to do was tear down the barriers of adoption for our customers. When they choose RHEL, they get RHEL. Regardless of the underlying hardware platform that they choose to run it on, they should expect to see the exact same experience, from a set of virtualization capabilities to container enablement technologies with the OCI format. They shouldn't have to stop and think, if I go with a mainframe, I'm going to have to go look at a different distribution in order to get containers running. It just wasn't a model that was working. We needed to have that dedicated focus. We couldn't pull people away from individual engineering product teams. What we had to do was build essentially a parallel organization whose sole responsibility that I lead is to enable multiple architectures. That includes Power, ARM, S390X. How do we get all of these architectures up to the level of having feature parity and do so without disrupting the core product teams? So we have a dedicated set of engineers that don't have to come in and spend a portion of the day working on the Power architecture. They get to come in and actually work on the next generation of cognitive computing by enabling RHEL for Power. Just the mentality that they were dedicated to something, and we laid out the plans, the vision to them in that fashion, actually have people excited to come in and work on these new architectures. Whereas before, it was pulling them away from moving into the latest, greatest container technologies to stop and backport work that they did 18 months ago into a new architecture. And of course, the goal is not just delivering an operating system. It's why do people need an operating system? Well, it's to run their applications on top. So we needed to look at the portfolio products that Red Hat provides on top of RHEL, our OpenStack offering, our Rev virtualization offering, our OpenShift container management platform. These are what customers are coming to us asking for. They're not coming to us and saying, we need RHEL. They're saying we need a way to run containers. We need a way to manage our virtualization. We need to build a private cloud using OpenStack. And that's the direction that's helped us really focus these areas, not just on the operating system, but the operating system plus what the customers are looking to run on top of it. I mentioned earlier the value of the operating system. I think VMware 10 years ago claimed the operating system was dead. I still don't think it could be any further from the case. The operating system itself is responsible for doing all of that communication to the hardware, making sure that the system calls in the kernel ABI doesn't change, making sure that if you're running on x86 or you're running on Power, the same tooling, the same commands work regardless of what hardware you're running on. And we saw a great example of that in the keynotes this morning with Oregon State, showing the two compilers side by side doing the exact same task, running RHEL and not caring the fact that one was a Power architecture and one was an x86 64-based architecture. To help also manage these common tasks, the automation, the management of the infrastructure. We need to provide a common interface in a common way so people don't need to stop and say, if this is Power, I need to manage this differently than I would an x86-based infrastructure. And the most important thing is connecting the applications to the dependencies that they have, all of the libraries that are required for these applications to run. So that was also a very large effort on our part is, a modern Linux operating system, I believe RHEL has upwards of 4,000 packages in RHEL 7. That's a hell of a task trying to make sure that everything is built for no arch compatibility, that when it compiles and builds, it's going to work on all these architectures. There were a few instances where some of these packages, some of these dependencies were archful, very specifically targeted for one architecture or another. And I actually use, kind of the container technology 3 to 4 years ago of that exact example. Containers were built with only x86 64 in mind, top to bottom. No way around it. Everything about it was all about x86 computing on Linux. What we saw is a major effort. Google helped with that, was heavily involved. SUSE was heavily involved with us, working on how do we take that and how do we scale that to these other architectures. And not just the ability to run containers, but Kubernetes. How do we take the frameworks that are managing containers and port that so it doesn't care about architecture? When I do a run C Postgres, how do I know that the container that I get has the right base image? I'm not going to try to run an x86-based base image on a Power-based server. We created the feature that are manifest lists that actually send server information up to the registries so it knows what proper packages and containers to send down. So there's compatibility. And that had to all be designed and built within the last 2 to 3 years to help support this push of multiple architecture, to make sure that the containers were possible on Power architecture in the first place. And that's the most important thing, is making sure that we remove that thought process from the operators, the sysadmins, that they don't need to stop and think, well, this is Power, so I have to do something differently. We're fundamentally, with the operating system, building it up so that the user space and everything that the consumer sees, uses, and runs is identical across all of the architectures. Why does this matter? We go back to, I believe if we go back far enough to the left, we support back to Power 5 with what Red Hat was doing. But looking at all the architectures going forward, Power 7, 8, 9, there was mention of Power 10 coming online in 2020. So historically, the OEM has been IBM. Well, now with OpenPOWER, we see significantly more vendors opening up the space. We see a lot of hardware vendors out there on the show floor with Hitachi, Wistrom, Inspur, NEC was out there. The growing number of hardware providers and OEM, ODM providers is growing using the Power architecture. So starting with Power 8 and our involvement with OpenPOWER was making sure that we conformed to the standards, worked closely with IBM and the partners to be able to provide that common operating system experience, provide those OS capabilities that historically have been missing on Power. And as we made the transition from a big endian focus to a little endian focus with Power 9, was making sure that we got our virtualization capabilities, our container OCI capabilities up to where we needed to be, making sure that we're driving ISVs. We're now a part of the Power AI offering from IBM. We have SAP HANA certifications for Power 8, starting to work with them on the upcoming Power 9 and getting certification with SAP for that? How do we continue to grow those ISVs and ultimately get into the use cases where the power architecture is taking us? Cognitive, artificial intelligence, machine learning, big data. These are the real opportunities that we see. It's not about running an operating system, but it's enabling the use cases that we see on top. And we want the operating system to be able to essentially make that invisible to the users as to how they get there, and make sure that power is treated as a tier one architecture for the customers looking for, what is really the highest performance, performance value that's out there. So what do we do? How do we enable the hardware partners? We have to have partner alignment. We can't just go out there and turn on all of our applications, all of our use cases for everyone. We work very, very closely with our partners, and we very specifically look at what are those use cases. So those use cases that I mentioned in that previous slide, we worked incredibly closely with IBM and our partners to know where they were building the power architecture to go in the future. If someone comes to me and says, hey, we want to go put Power 9 at the edge in the telco, I'm probably going to say, not a chance. Nothing we've done up to this point was built to accompany that use case, the networking capabilities, the NFV, to that level. It has not been identified as a use case. We're not actually going to start building these capabilities just because the architecture is available. We want to make sure that we are aligning to the proper use cases, and we can only do that through communication with our partners and invest wisely. All the way through product delivery, making sure that what we send out the door is something that works, has been validated, has been tested in alignment with our partners. So when a customer sees this and receives this, he knows it's going to work through hardware certification, through other mechanisms that we put into place. And even working with our partners on helping do field enablement, making sure we're highlighting the benefits of what power provides. The high performance, really, moving towards the exascale computing, the cost per performance, all the numbers and information that we've seen throughout the day is really where we see this leading. And we do a lot of enablement with our hardware partners to get the marketing messaging right, to help get out the door and help deliver solutions as partners, not we're going off and trying to do this alone. IBM's going to go tell a different story. Inspir's going to tell a different story. It's all aligning to, aligned to what those use cases are and where people are moving in the market. So in terms of just enabling these hardware partners, we have, alone with IBM, over an 18-year history in partnering with them. We provided support since Power 5. Around late 2005 is when we started to invest in Power, back when it was only Big Endian. And that's continued through Power 6, Power 7, Power 8 into the Little Endian transition, and going to continue on to Power 9, and we'll see what happens as we get to 2020 with Power 10. We have a very strong ability to enable our new partners, platforms, and architectures quickly. Everything that Red Hat does is 100% upstream first, no matter what. We will never put anything into a downstream Red Hat product without it being accepted by the upstream community. And that's one of the values that we like to provide, is we have the engineers that are contributing the code, a lot of times are the maintainers of the code or specific sets of functionality, to make sure that we're always committing to the open community, open standards upstream first. As we pull that down and work with our hardware partners, we also have a full hardware certification program. And that includes certification kits for Power 9, making sure that when customers get the hardware, there's a level of confidence that what they get, the operating system that runs and the applications on top of that, are going to work. And when they work, it's going to work for a guaranteed period of time. So one of the things that we have is a 10-year support lifecycle on any major version of RHEL. What that means is any application that's built based off of any version of, say RHEL 7, whether it's 7.1, 7.2, 7.3, it's going to continue to work throughout the entire lifecycle of that RHEL release. No application changes needed, nothing needed by the ISVs or hardware partners to make sure that we maintain compatibility across versions. And as we saw earlier today, we have that consistent set of compilers, libraries, and tools to make sure that if you build for multiple architectures, it's going to build the same way, using the same commands and using the same tools to get the code built, compiled, and ready to run for the consumer. One of the things that I think everybody in the community, everybody in OpenPOWER needs to focus on, and this should be a strong focus for 2018, is attracting the ISVs. Again, it's all about the workloads that you need to run on the platform. It's absolutely vital to the success of the OpenPOWER Foundation to align and grow the number of ISVs committed to the Power architecture. Coming from Red Hat, we have an office up in northern Massachusetts. Long history of DEC, HPE employees that once all those got bought out and went out of business from DEC Compaq HPE, they all landed at Red Hat. So we get to hear a lot of stories from the people that have been around a while about alpha processing. Some say that architecturally it was the most advanced processor of its time, could run circles around anything else out there, had zero ecosystem outside of the Compaq DEC ecosystem. Software partners weren't lining up to use it. Ultimately it failed because you couldn't run anything on it outside of HPUX. The Itanium. Again, it's a very similar story. Intel built a very high performance, architecturally advanced chip. If you weren't building your own custom applications, there weren't lines of people outside of Microsoft that were running on the Itanium architecture. It also helped cause that to ultimately dwindle in the market and not be as successful as Intel would have liked. We are seeing some great advancements with the Power architecture with partners like SAP coming on board. Very large opportunities in the big data, especially in the cognitive space, as we have new companies, new libraries, new startups coming, such as TensorFlow, Caffe, Torch, all coming on board with the mindset of open source from the start, that we're already starting to build up an open source ecosystem around the Power architecture. And I think that we need to continue to maintain that and push that and use these opportunities for growth of where Power is going to be successful to help us to continue to grow that ISV ecosystem. And that, of course, has to align with the enhancements that we see in the hardware capabilities, making sure that we're taking advantage of CAPI, NVLink, NVLink 2, all the new capabilities coming on board, that is a combination of bringing in the right hardware partners, aligning the right software partners that can leverage the hardware. That ultimately is what builds up the ecosystem. And I think that that's something that will be the critical success factor of OpenPOWER and Power as an architecture in general. One quick slide just on Red Hat and your business. What we try to do is Red Hat goes out of its way to drive stability, flexibility, and certainty in the mission critical application workloads that you provide. So we continue to meet customer challenges with solutions such as container management, container orchestration, cloud management with OpenStack, starting to get into the hybrid cloud mentality of running portions of your infrastructure on your local cloud as well as off in remote or public clouds, and effectively managing that the same way as if everything were on site. Ability to have certainty that your mission critical applications will continue to run, that security fixes, security patches are delivered in a timely manner, and continue to push the boundaries of stability and performance for your customers. And one of the key things to highlight as to why we feel we are going to see critical success in the HPC space is, this is probably even higher now, but going back to 2014, more than 97% of the top 500 in the supercomputing list are running some version of Linux. And I think this is now up to all of the top 50 at this point are running Linux. Definitely, it's quickly becoming a Linux-only world in order to play in that space. I could probably get a more recent source than something 4 years ago. We know the top 500 is coming up again, and we have very big players that are coming in. We see the new capabilities with what the Coral Labs are doing. I think they have very, very reasonable expectations to be #1 on that list with what they're building with Sierra, right? Isn't the new one? Summit, yeah, Summit in Sierra, based on which lab you are. And we, had a mention of, by one of the Oak Ridge presentations around the Titan, which is their previous generation, which is moving to the Summit. Oak Ridge. Oak Ridge is moving to the Summit supercomputing, which is supposed to give, I think, double the performance at half or 1/3 of the total system capacity using the Power 9 architecture. So great opportunities to drive forward and really take over the world of performance with a small number of systems that are incredibly high performing.